Hey guys, we're just going to go through the plan for question 3 in the HSC circle geometry questions. We're going to use the same approach as we normally do. We're going to look at what the question gives us to try and eliminate some of the rules. We're going to look at how many marks it's worth in terms of how many reasons we need. Normally we'd look at parts, but this doesn't have it. And then of course we're going to make sure we use everything they have given us. So let's have a look at this question. Two circles C1 and C2 intersect at P and Q as shown in the diagram. The tangent, very important, TP to C2 at P meets C1 at K. The line KQ meets C2 at M. The line MP meets C1 at L. I have to copy the diagram, but I do have to prove that triangle PKL is isosceles. From that diagram, I'm going to guess that I have to prove these two angles are the same. So we're going to have to prove that alpha equals beta. We could prove that the distances are equal, the chords LK and PK, but odds are it's going to be those angles just because we have so many more rules that deal with angles. So let's have a think about some of the rules we can eliminate. First of all, there's no centers. So anything to do with a radius or a diameter is gone. We do have a tangent, but we don't have a secant or another tangent drawn from the same point, so those rules are gone. In fact, the only rule that's left with the tangent is the angle between a tangent and a chord. So odds are we are certainly going to use that. So angle between tangent and chord. The other one are just a lot of chords, but one of the circles has a cyclic quadrilateral. L, K, Q, P is a cyclic quad. So I'm going to guess that we're going to be using that as well. So let's get started on this proof. We have a tangent, TPK, but that's a tangent to circle C2 only. So we need an angle in C2 in order to use that. So in this particular case, I think starting with beta is probably the best idea. And then our first reason is just going to be vertically opposite angles. Not a circle geometry reason, but could be one of the three that we need, this being a 3-mark question. We'll see how we go. Once we've got that, that gives us the angle between a tangent and a chord is equal to the angle subtended in the opposite segment. So this angle over here is beta. And now we've used one of the reasons we knew we were going to. So angle between tangent and chord. One more reason we would expect, and it has to do with the cyclic quadrilateral. So the cyclic quadrilateral LKQP, that angle here is an exterior angle, and of course that's going to be equal to the interior opposite, which actually ends up finishing our question. So we're going to use the exterior angle of a cyclic quad to prove that alpha is equal to beta. I would finish this question off by making sure I actually answer the question. Once I've established that alpha is equal to beta, finishing with the line, therefore PKL is isosceles as two angles are equal. But otherwise, we've finished off that question. 3 reasons, plus a little finish.